Okay, so like I said, welcome to week 2, lecture 4, the last lecture of the week. And we're going to look at some facts or some information about isotopes today. And last day, I was talking about 3 isotopes of neon. And I mentioned that they have different abundances, different amounts in nature. They're not always found in the same amount and not even close. So if I told you there were 3 isotopes of neon, you know, you might think, okay, 33, 33, 33%, but no, they're completely different. And these relative abundances we will use today, if I have time, I think I will, to calculate a very important number in chemistry called the atomic mass. And the atomic mass is not the mass number. So before we do that, I just want to show you an example. This is a question you will probably see on your first test. Okay, your first test being in week 7 or week 8 in October. So a long time away, but you will have a test early October. And you might see a question like this. So I want to show you this one. And then I'm going to ask you guys to try this one over here. So first things first, these are isotopes. These numbers that I'm circling, these are the mass numbers. So like in English, like speaking, I would say this would be neon 20. The first one, right? Neon 20. So neon 20, we could write it in this, it's called nuclide notation. You don't have to worry about what the word, or like the word nuclide, it's just like a chemical notation. A chemical formula for writing this. Instead of writing neon 20, we can write it like this. And that gives us a lot of information. So I know that neon has mass number of 20 and 10 protons. I can get this number 10 if you guys don't know where that 10 comes from. It's because it's the number above neon on the periodic table. Okay, so it's the atomic number, it's the number of protons, and all neon atoms or isotopes have the same number of protons. Okay, so this guy here would be neon 21. We still put a 10 there. This guy here would be neon 22. We still put a 10 there. That doesn't look like a 10, does it? Oh, my pen. Sorry. Ah. Okay, so let's finish this table. Neutrons, remember, is your mass number minus your number of protons, or your mass number minus your atomic number. So it's pretty easy. Here, it would be 21 minus 10, which is 11. Here, it would be 22 minus 10, which is 12. All right, cool. And then our mass number, of course, this is easy because it's the number written next to the word. So neon 20, neon 21, and neon 22. So I have all of my information there. And what I would love for you guys to do is on the next slide, try a couple of these. Now, you might be missing some information here because I haven't given you copies of your periodic table yet. I probably should have done it in the safety lab, but I wasn't thinking about anything else other than lab safety. So let me just get you these atomic numbers so you can get this done. So I want you to try this, but let me get you atomic numbers. I'm just going to pull up a periodic table, make sure I don't mess up any of my numbers. So I don't even have the periodic table in front of me, not the college one. I am just using Google and typing in periodic table and getting a nice picture of it. So carbon I know anyways. Our atomic number, again, this is the number on the periodic table above your element. So if we were in class right now, you would see this. It's literally on the wall in the classrooms. And if any of you guys are sitting in the classrooms, you can look above calcium, for example, and see that the atomic number of calcium is 20. And you can look above carbon, the number above carbon is 6. And you can look above aluminum. The number above aluminum on the periodic table is 13. The only other thing I really need to tell you is that, remember, in atoms, because they are neutral, and isotopes are the same thing, because they are neutral, electrons are equal to protons. That's for atoms and isotopes. So I'm going to stop talking. I'll put myself on mute for a minute and see how you guys do with this table. So I'll be back in 2 minutes. Okay, so let's go through our answers here. I guess I should have mentioned or told you as well is this is a very important practice problem that you will probably see on test 1 and your final exam. So this is definitely something you want to make sure that you know for your final exam. And I know your final exam is months away. It's not until December, but here we go. Let's get our numbers filled in. And again, in the chat, I had a student, looks like she got them all right. Let's see. Okay, so atomic number, I wrote them over here on the side. So this would be 26 and 13. All right, so again, these numbers come from the periodic table, and I will show you in a minute where you can find your periodic table on the D2L. And hopefully next week I can get a periodic table to you. The mass number, that's the easiest one because it's written right here. Okay, this does not come from the periodic table. Okay, the mass number is a whole number. And a whole number, if you can't remember what that means, is like 1, 2, 3, 4, 5, 6, 7, 8, 9. No decimals. So the mass number comes from the name. So 40, 13, and 27. Okay, again, comes from the name. Now, to find protons, this is pretty easy because protons are equal to the atomic number. So 26, 13. And I mean, while we're at it, why not do electrons? So guys, if you see the 3 things I have circled right now, atomic number, protons, and electrons, these are all the exact same number. Right? It seems weird to write the same number all the time, but remember, the atomic number from the periodic table is what are represented, or what does represent the number of protons in that atom. And remember, atoms or isotopes, they are neutral, so the protons and electrons are the same. So really the only challenge here is calculating the neutrons. And all we need to do is subtract mass number by number of protons. So we have 20, 40 minus 20 is 20, 13 minus 6, I think that would be a 7, whoops. And 27 minus 13 would be what, 14? I think. All right, so this is definitely something you need to know. All right, and it looks like in the chat there, Sophia got it perfectly correct. Okay. So I just had a message in the chat as well about me putting something on D2L, and I did put something on D2L. Let me share my screen here. Well, let me open your D2L first, and then I'll share my screen. All right, so let me share my screen. This is kind of important for you guys. If you miss your lab next week or you lose, if I manage to get you a copy of your periodic table and you lose it or something like that, I have it up here for you. This is a new, I'll start up course information here. This is a new periodic table. It's been developed over the summer, so it was just recently updated from a few semesters ago, and you can find it here. And in this little place in your content, I will have other documents too. So in things like infographics, little like study guides and things, like basically anything that doesn't fit into the other topics. So you'll notice I have lectures, labs, worksheets. Well, anything else will kind of go in here. And one thing that's in here already is your data book. So if I click on data book, it will open it up, right? So this is the data book that all chemistry students get. And it looks really intense, but all you guys need to do is go to the last page. And I know it's sideways, but when you print it, it'll look much more normal. But this is your periodic table here. And again, if you don't have a printer, you can print this at school. And my goal is next week for you guys in the lab to print off a ton of periodic tables and have them in the lab. The only problem is I won't be in the lab until 11:30 on Sunday. So just keep that in mind. If you're one of the students with the 7:30 or 10:30 labs, they might not be there yet. Anyways, so this, where I just told you guys, this page here, anything important or useful, I'll be putting down here over the semester. Periodic table and other useful information. It'll be kind of like, infographics or study guides, things like that. Okay, so let's go back to our notes here. I'm going a little slower than I thought, which is fine. I don't mind. We got lots of time. Actually, no, we're doing okay. If I could get through at least one of these examples today, I'd be a very happy person. So you give me a little bit more time, maybe 10 minutes or so, we should be okay. What I might do is do one of these examples and then leave one for you guys to try over the weekend for practice. Although I know you have a lot of work to do, but up to you. Okay, so we've been talking about isotopes. We've been talking about mass number and all that. What does this mean for us or to us in terms of, chemistry 1120? What are we going to do with this information? Well, in chapter 3, we will start what I would call like the real, well, I don't know, I'm biased, but the real chemistry. It's, we'll be talking about chemical reactions and stoichiometry, and which is kind of like a recipe for a chemical reaction. So one of the most important numbers in that calculation is something called the atomic weight or atomic mass. I know the mass and weight aren't technically the same thing, but depending on the periodic table you're using, it will say atomic mass or atomic weight. Very important note here. Sorry. Very important note. Mass number is not the same as atomic mass. Okay? Mass number is protons plus neutrons. It is a whole number. So mass number is a whole number. Atomic mass will have decimals. Now, that is not the definition of them, not by any means, but that's how you can tell the difference. Every single semester for 12 years, and not one class has actually done this. Not one class in 12 years. That's a lot of classes. Every year, somebody puts the atomic mass here. So they would put, for carbon 12.0107. Every year, somebody does it. And not once. And I always challenge my students, if I can, before I retire, get one class to get this right, it would be a dream. Mass number is not from your periodic table. I cannot stress that enough. The atomic mass is from your periodic table, and it will have decimals in it, okay? And we're gonna learn today how to calculate the atomic mass, and then I'm gonna show you where you can find it. And that's it for today. We'll just do one example here, because this will take a few minutes, and then I'll leave the other one for you guys to practice. So let me just open the chat. I have a message there. Aman has a question. Ask away. And while she's typing her question, just to make a little note there, the formula on the bottom of this slide looks really complicated. It is not that bad when we actually use it in practice. Iman's question is really good because it's a tough, how do I answer it? So the question is, will I give you the mass number because it's not on the periodic table? And the answer is basically yes. So Aman, or anybody who is curious, let me just clean up my slide here. I'm sure I could right click and get rid of all this real quick. So the question again, will I give you the mass number because it's not on the periodic table? The answer is yes, but it might not be direct. Meaning, if I don't give you this number, I would have to tell you how many neutrons. And if I gave you neutrons, it's easy, right? 20 plus 20 is 40. So for anybody wondering, Aman included, I will always give you the mass number or neutrons. And if anybody wants practice on this, I've uploaded on the D2L a bunch. There's 5 worksheets, and this would be covered on the worksheets. There are also answer keys to all of the worksheets. So anybody who wants extra practice, there are worksheets online. There's at least 5 for chapter 1, and they all have answers written. So long answer made short, yes, you will get the mass number. And if you don't, I will give you neutrons, and then you can calculate mass number. Okay, so back to this. I just want to do one example with you, and we'll call it for today. So, atomic mass. How do scientists calculate atomic mass? Well, what they do is they take the masses of all the naturally occurring isotopes, and they use their relative abundances. Remember what that is? It's their percents. And they calculate what's called a weighted average. A weighted average is or can be a challenging thing to calculate, but I'm going to show you how easy it is, I hope. This formula looks complicated. This means sum, which means to add together. So what you do, and again, I'll show you this in an example. It's not as hard as it looks. But what you do is you take the mass of the isotope and its abundance and multiply them together. And you do that for every isotope. and then you just add those numbers together. It's called a weighted average. It's literally the same way I calculate your grades. So if your final exam is worth 50, I take your exam grade and multiply it by 0.5, which is 50% as a decimal. And your labs are worth 10, so I take that and multiply it by 0.1. And I do that for all of your marks. And then I just add them together. It's called a weighted average. So let's, like, again, pretty easy. Let's have a look at this. I think it's easy. I hope. Gallium, so next slide, first example. Gallium has two naturally occurring isotopes. Okay, so there's gallium-69 that has a mass of this 68.9256. Now the units we typically use are AMU. These are atomic mass units. The only time you'll see this is in chapter 1. When we get to chapter 3, we will use the units grams per mole, but we haven't really got into grams or moles yet. So the mass is 68.9256 AMU, which means atomic mass units. Whoever created that wasn't very creative, were they? You know, what unit will we give atomic mass? Well, we'll call it an atomic mass unit. Anyways, I thought that was funny. This is your abundance. So this is information for gallium-69. And watch what I'm going to do here. So gallium-69. I'm just going to make a note that it has 68.9 256, and that it has a percent of 60.11. I'm going to do something with that number in a second. So if you guys are writing with pen, just maybe wait for a minute. If you're not writing, that's fine too, because you don't need to. Okay, so gallium-71 is 70.9247, and it has an abundance of 39.89. Okay, so watch how easy this is. And I wrote it like this for a reason. What you do is you multiply these numbers together, and then you add them up. Add up your answers. So one thing, when we multiply these numbers together, I don't want to use a percent. I need it. If you can think back to math class, we typically don't use percents in our calculations. We convert it to decimals. So can anybody in the chat tell me, how do I change 60.11 to a decimal? This is a math question, not a chemistry question. I want that as a decimal. I get divide, and I get that somebody, yep, I'm getting the answers there. Okay, I'm getting a good answer as well from Sophia. I like it. And Aman, you're right, we divide. Okay, cool. So that's right, everybody. We divide by 100, and Sophia had a good little statement as well. You could just move the decimal 2 places to the left. So you're exactly right. So what I'm going to do is I am going to change the percent to a decimal. This is not a chemistry question. This is a math question. But you do that by dividing by 100 or moving the decimal 2 places to the left. So I get 0.6011. Here I get 0.3989. You can do that on your calculator. You can do what Sophia said and just move the decimal, whatever you want. But now I'm just going to put these numbers in on my calculator. Okay, so let's get my calculator open. I don't have the answers, right? So I'm going to do this along with you. We'll be done right after this example, guys, don't worry. So the first one, 68.9256 times 0.6011, and I get 41.43. Now, I can only use 4 significant figures in my answer, but I will keep a couple extra numbers in my calculation. Okay, the units for this are just AMU. I'll do it for the next one. I have a message popping up in the chat there. I hope I didn't make a mistake. I'll check it in 1 second. All right, so here I get 28.29186, so I'll just say 19. I don't want to round. You don't want to round too much, but I know that I can only have 4 significant figures, or in this case, 2 decimal places. And all I do now, guys, is add these 2 numbers up. And that's it. Okay? If I had 3 isotopes, I would do it 3 times and add them all up. Okay, everybody's good. I'm getting lots of answers there from students. They look to be good. Sophia, I know, is getting the same thing I'm getting. So I'm just going to add these up. Now remember, sorry. Remember, watch your significant figures. I can, like this tells me I can only have 4 significant figures in these answers. And because I'm adding them, my answer will only have 2 decimal places. So my answer will be, and I'm using my phone here. If I had a nicer calculator, I wouldn't round these at all. I would store the numbers in my calculator. So if any of you have a nicer calculator, your answer might be slightly, and I mean extremely slightly different. But my calculator is telling me I get 49.723, but I can't have that 3 there. So 69.72 AMU. And there we go. That is my atomic mass. This would be the number on your periodic table for gallium. Yeah, exactly. Yeah, Sophia's getting the same thing I am. So, okay, I'm getting some questions on sig figs. So I'm pretty much done for today, everybody, but I will answer these questions on significant figures. And that's it. Well, you guys can go. So, okay, quick little explanation about sig figs. So let me clear some of this. Okay, so let's go back and look at this. This number, like, okay, all of these numbers here, they all have the same amount. They all have 6 significant figures. All of these numbers have 4 significant figures. So when you multiply, you take the answer with the lowest number of significant figures. So that means with this answer on the right, with the 41.43, only these numbers that I'm circling are significant. But so why did I put these there? Do not round your answer till the end. We do not round until the end. So, okay, I wrote 41.4311, 28.2911, but remember, only 4 of these are significant. So because I'm adding, I need to take the lowest number of decimal places, and they both have 2 decimal places. Remember, that's your rule for adding. You always take the lowest number of decimal places when I add. So in my answer, I just get 2 decimal places. Total of 4 sig figs, but 2 decimal places. Okay. I hope that explained it. And so tomorrow, well, tomorrow's Friday, so you guys do whatever you want. But Monday's class, we're going to do another one of these. Okay, we'll do this one. And you can see this one's going to have crazy significant figures. So we'll talk a little bit more about this one on Monday. And if you're bored over the weekend or you're waiting for me on Monday to show up to class, you can try slide 70. Okay, other than that, I'm done. I hope you guys have a fantastic weekend and you wash your hands and you wear a mask and you drive safe. So yeah, I'm going to hit stop record. Have a great weekend.